Good morning, students. Welcome to the class of physics. In today's class, I will discuss about the nature of graphs of oscillatory functions. When I meet students, they are very confused that why oscillation oscillations are called sinusoidal functions and why these are have why these have sine or cos graphs. Let's take a look why oscillations are called sinusoidal functions. First of all, what are oscillations? Oscillations are the to and fro motion of a body. For example, the movement of a swing, the movement of a pendulum. Why these are called sinusoidal functions? These are called sinusoidal functions because for measuring the displacement, the velocity, the acceleration, the time period of an oscillation, we need to study about the graphs of sine and cos. Let's start with that. First of all, let's take a look on the values of sine theta and cos theta. As we all know, sine theta's value for theta 0, 30, 45, 60 and 90. It's 0, it's 1 by 2, it's 1 by root 2, it's root 3 by 2 and it's 1. And for cos theta, it's 1, it's root 3 by 2, it's 1 by root 2, 1 by 2 and 1. Now I have already told you what are oscillations. Oscillations are the motion is a to and fro motion of a body. To and fro motion of a body. Here I am taking an example of a pendulum. Now, what is pendulum? It is a point where a string is attached and it is called bob. This position is called mean position. Now, when we move a bob from this position to this highest point of a position, it is called extreme position. Now look, let's take this example through graph. This position is mean position, means origin. This point is here, origin. We are taking it in the upward direction to the maximum height, which is called extreme position. Means we are taking it to the maximum height. Graph reached there. Now, what happens? This bob will come back to its mean position again. Means this graph will come down again. Now, what happens in next term? This bob will move in another direction to its mean position. Extreme position. Means in opposite direction, it will also attain its maximum value. Now next, what will happen? It will come back to its mean position again. Come back to its mean position. Let's compare it with sine theta. We already know there are 4 quadrants: 0, 90, 180, 270 and 360. Sin theta moves. How it moves? It moves from 0 to 90 as maximum value. Na? 0, 1 by 2, 1 by root 2, root 3 by 2 to 1. Means it moves from 0 to 90 and regularly increasing. Similar thing is happening in this graph. The movement of the bob starts from its origin, means from the 0. It has attained its maximum value. 1. Now in second, it then reaches from maximum to 0. Why? Because sine 180 is 0. So now it has come back to 0. Now bob is going to another side. Means we all know sine theta graph is positive in first and second quadrant. So look, our graph already lies towards the positive part. Now when it moves from 180 to 270, at 270 sine 270 is minus 1. So it will attain its maximum value in opposite direction. Then 270 to 360. Sine 360 is 0. So it is 0. Clear? Why the graph of oscillation is of sine theta and why we take it as sine theta functions or sinusoidal functions? It is the explanation of sine theta. Now I will explain you about the cos theta. In case of cos theta, what will happen? It is the position, mean position of. In this case, the object will start oscillation from this highest position. Means its extreme position. Now what is going to happen? In cos theta, cos 0 is 1. Means with the increase of angle, value of cos theta decreases. Similar thing happens there. Graph will start from extreme position and will reach towards its mean position. Means it has reached to the mean position. Means 0, maximum to 0. Now from here it will move towards the another direction. Moved towards another direction and attains maximum height. Now look, when we talk about quadrants, first, second, third and fourth, cos theta is positive in first quadrant and fourth quadrant. That means during second and third quadrant it is completely negative. Now look, when it moves to this direction, its graph is moving towards negative part. Now it will come back. Now a bob will come back to its mean position. Back, graph becomes 0. Now what is going here now? Graph will again move towards extreme position. Clear? Means this value is 0 to 90. This value is 180. Why? Because cos 180 degree is equals to minus 1. This value is 270 degree and again this value is 360 degree. Clear? This is the reason why oscillations always are called sinusoidal functions, because these motions are represented completely by sine and cos function. Now, next question. One next question. Why we need to represent the value of angles in radian form, not in degree form? इसका आंसर क्या होगा? देखो, when we try to calculate the value of pi is the value which is a ratio of circumference of a circle to the radius of a circle. Clear? When we talk about the oscillations, the string of a bob, its length always remains the same. That means if we compare the radius of a circle and length of the string of a pendulum represents the same. कहने का मतलब कि अगर हम सर्कल के रेडियस की बात करते हैं और अगर हम बॉब के स्ट्रिंग की लेंथ की बात करते हैं तो वो एक ही तरह की इक्वेशन बना रहा है, एक ही तरह की क्वांटिटी को रिप्रेजेंट कर रहा है, क्योंकि रेडियस भी किसी एक सर्कल का कभी चेंज नहीं होता, वो हमेशा कांस्टेंट रहता है. क्लियर? रेडियस किसी भी एक सर्कल का कभी चेंज नहीं होता, वो हमेशा कांस्टेंट रहता है. सिमिलरली जब हम किसी भी एक ऑसिलेशन की बात करते हैं, वहां पर भी अगर हम स्ट्रिंग की बात कर रहे हैं, किसी भी मोशन की बात कर रहे हैं इन ऑसिलेशन, स्ट्रिंग की लेंथ हमेशा सेम रहती है. अब अगर उसकी स्ट्रिंग की लेंथ सेम आ रही है तो इसका मतलब उसकी एक्सट्रीम पोजीशन बोथ साइड पे सेम होगी. क्लियर? और इसी तरह से अगर सर्कल हमारा सेम रहता है तो उसका सर्कमफ्रेंस भी एक सर्कल के लिए कभी चेंज नहीं होगा. मतलब रेशियो ऑफ सर्कमफ्रेंस एंड द रेडियस ऑफ सर्कल ऑलवेज रिमेन constant. Similarly, length of string and the distance of extreme position, or we can say ratio of distance of extreme position and the length of the string of a pendulum is always constant. And we compare both these concepts and use the value of pi there. Clear? Why we are not using degree angles in sinusoidal functions and preferably use the radian values. So now, if you have any query or suggestion to improve, please do comment. Thank you.